Hello everybody and welcome back. I hope you had a great spring break. Yeah, I know I wish it was still going on, but it's not. So we're going to go ahead and get started on our last unit, which is Unit 9, Variations. So there's two different kind of variations. One's direct, one's inverse, and then we're going to deal with the word problems of it. So this unit is very, 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 very short, and it was made to be short too. So we're literally doing 3 days of notes and then an assessment, and that's it. Okay, so let's go ahead and get started. Today we're going to focus only on direct variation, so because that one is probably the easiest one for you guys to wrap your head around, because it's something you've already been dealing with. You just didn't know it was a direct variation. And then we'll move into stuff that's a little bit more abstract and then dealing with word problems. So direct variation. A direct variation is a linear function, so it's going to make a line when you graph it, still dealing with x and y, defined by the equation of the form y equals kx. So very similar to slope-intercept form, okay? Except it just doesn't have an intercept on the end. There's no b and there's no m, alright? And for this situation, k does not equal 0. So it's not going to be a horizontal line, okay? It's also not going to be a vertical line, so you don't have to deal with any horizontal or any vertical in this whole situation, okay? So the x and the y in the equation, those have to stay the letter x and the letter y, okay? Because that allows us to plug anything in for x and y and figure it out. The k, however, that should be a number, and that k is called a constant of variation, okay? It's a non-zero constant k in the function, blah, blah. It is basically acting, it's very, very, very similar to slope, okay? Very similar to slope. So, if you have to graph it, you can kind of think of it that way. However, because it's, so even though it's a linear equation, and we kind of have something that's similar to slope in there, the reason it's a whole separate unit is because of the relationship that these ordered pairs have. So this is the formula you will always use for a direct variation. I'm warning you now, the inverse variation is very, very similar. So commit these to memory however you can, okay? To find the k, because remember I told you this is the only thing that should be a number. To find that k, alright, you are going to use this formula. And this is what makes a direct variation special from other linear equations. So what makes it special is that every ordered pair, every xy combination, will always give you the same k value. So instead of trying to find slope, like with a normal linear equation, we found slope by using 2 points, we can actually find the k just using 1 point for the direct variation. Because they have a very specific relationship. Whenever you divide the y value by the x value, you're always going to get the same k. So that's what makes it special, and that's why we have a whole separate unit. Okay? So another thing that's very special about direct variations is that they're straight lines that always go through the origin. So it will always pass through the origin. If it doesn't, it's not a direct variation. It could still, something could pass through the origin but not be a direct variation because it doesn't have that special relationship to get k. But every direct variation that has that special relationship will always go through the origin, because 0 divided by 0 will always work. So here's some examples. All it's asking is it a direct variation? So when you have y by itself, does it give you that y equals kx? So this one, it's already y by itself. 6 must be your k times x, so it's already in this form where k is 6. This guy, I need to get y by itself. So divide this, or to get y out of the denominator, I'm going to multiply both sides by y. So now I have x equals 1/3 y, but I just wrote it as y over 3, because that's a little bit easier than dealing with a fraction. And then I just multiply both sides by 3 to get y by itself. So now I have y equals 3x. So y equals 3x is in the form of y equals kx, where k would be 3. Okay? So you're going to try these two on your own. Ooh, kind of gave you an answer there. Try these two on your own. If it is a direct variation, write down what k is. Okay? So here's a word problem. So a lot of other teachers consider this a word problem, which I guess it is. I consider word problems to be like real world problems, so I just bulk everything into that phrase. But this is one you'll see pretty often. What it does is it says suppose y varies directly to x. So it tells you it's a direct variation by this phrase right here. Let's see if I can get varies directly, direct variation. Okay? What it also tells you is 1 point. Y equals 3 and x equals 2. So that's one of the points for this line. Find x when y equals 3, when x equals, find x when y equals 6. Okay, so it looks like there's not a lot of information, but it actually is. Because you know it's a direct variation, so you know it's going to be y equals kx. The only thing you don't know is what k is. So in order to find that, we're going to use the x and y that we do know, the 2 and the 3, and plug that in. Okay? And then we're just going to solve for k. So I go ahead and divide both sides by 2. I get k equals 3/2. And yes, it's okay if it's a fraction. That's totally fine. So here's what's important. Once we know our equation for this situation, y equals 3/2 x, we can use that specific equation to find a missing value. Okay? Now we can plug in y and solve for x. So now I'm just going to go ahead and get x by itself so I can figure out what that value is. And here I actually multiplied by 2/3 just so I didn't have to deal with dividing a fraction. Multiplied it by 2/3, I get x equals 4. Okay? And what's nice, what it does, it allows you to figure out a missing value with less information. When we had to do it with just like a linear equation, we already needed to know a couple of points in order to do this. Here, all we needed to know was it's a direct variation and 1 point, and we were good to go to find that missing value. And you could do the same thing with the missing y. The first thing you need to do, though, is find your specific equation for the situation. Okay, so you guys are going to try this one on your own. Okay? So example 3 is dealing with equations. Writing an equation for a direct variation is exactly the same as writing an equation for any kind of linear equation. Okay? You could do it where you could do it algebraically, where you find 1 point and figure out the k value. The only thing you want to be careful of is if it's asking if it's a direct variation, you want to find a couple points and find the k values for each one. If they're all the same, then it's direct variation. Okay? But, or you can treat k like a slope, which is the same thing. Just go ahead and start, I always start at 0, 0, since it should be going through 0, 0 anyway for direct variation, and then just go to another point. So here I went up 6 and over 5, so my k is 6/5. I could have found that by just doing the points. Well, this one's really the only clear point here, but I could have done the same thing. It's the y over the x, so the y value is 6, the x value is 5, so 6/5. Once I have that, I can go ahead and write my equation. So I didn't need the 0 part, because I started writing it like a linear equation, which you can, because it will just come out to be the same thing. The 0 goes away. But once you find your k, you can just go ahead and write it in. Y equals 6/5 x. And that's it. Guess what you're going to do now? You're going to do one on your own. Yay. Write an equation for a line. Is it a direct variation? So, this one, you have to tell me what the equation is for a line. So regardless if it's direct or not, you should be able to write the equation. And then tell me if it's direct variation. You should be able to tell if this is direct variation just by looking at the graph. Okay? So give that one a try. And then the last kind of example would be if I gave you a table and I asked to tell if it's a direct variation, and probably if it is a direct variation, I'll probably ask you to give me the equation. So when you have a table or just a bunch of points in general, the way you do it is you calculate the k for each one. If they all give you the same k, that means they all have the same relationship between their x and y. So it would be a direct variation then. Okay? And then once you have k, which would be all the same between all of them, you just go ahead and write it in the equation. So remember, we're dealing with y equals kx. To find k, we do y divided by x. So I'm going to do that for each ordered pair. So here, k would be 4 over 1, which gives me 4. Here I'm going to do 8 over 2, which gives me 4. So far, these 2 points make a direct variation. I just need to check every point to make sure. 12 divided by 3 gives me 4. Cool. Remember, check all of them though, because even if everything else works but the last one doesn't, it's not a direct variation then. 16 divided by 4 gives me 4. So because I got the same k value for each point, that means it's direct variation, and that same number is my k value. So k equals 4, so yes, it is direct, and my equation would be y equals 4x. And now you guys are going to try this one on your own. Okay? Alright. And that's it for the video. Sorry, it was very short, I think. Yeah, so not bad. And there are a lot of try and runs because there are a lot of different ways they can ask these kind of questions, so I just want to make sure you're prepared for each one. But luckily, after today, it should be a lot easier no matter what, because inverse, we're going to do the exact same thing as all of these, but we're just going to tell what's it using the inverse equation. And then word problems, you're using the same things, just dealing with more real-world situations, which I actually think are easier to deal with. So, if you have any questions, write them down. We'll answer them in class, and I'll see you next time. Bye!